So, welcome to this talk. So, my name is Marc Klefter, and I have a background as an engineer, consultant, startup founder, and other roles in various business and technical domains. And my focus for a long time has been on helping organizations build cloud-native systems, specifically using event-driven principles, patterns, and best practices. And that is also the context for exploring Dapr, which we'll do in this session. Dapr stands for the Distributed Application Runtime, and it's an open source CNCF project aimed at, as the name implies, developing distributed applications running in typical cloud-native environments, but not limited to those. So thought we would begin our investigation into this technology and its practical considerations by setting the stage, starting with the term distributed. So when you talk about a distributed application, we're talking about a loosely coupled term that is quite overloaded. Loosely coupled services, or application services, distinct processes communicating synchronously and or asynchronously, which is a fundamental assumption of Dapr, that this is the way our applications are structured. Dapr isn't limited to a certain environment, though we'll be focusing mostly on cloud-native environments in this talk. So we are assuming a container-based approach to packaging and deploying our applications, typically on Kubernetes as an orchestration platform, but you will find Dapr being supported on VMs, on-prem, even in serverless environments as well. Beyond that, the important topic is those of shared application concerns. So, in Dapr, you'll find support for common patterns, but some of them are supported by the native platform itself. So, for example, you have things like service discovery and horizontal autoscaling. That is provided by Kubernetes itself, natively. Then you have things that are more cross-cutting in their nature, such as resiliency policies. What do you have in terms of retries from one service calling another, circuit breakers, access control policies, and so forth. Those span across many services, and sometimes you'll find these being offered by service meshes, for example, something that Dapr is very similar to or offers similar functionality to. And then you have concerns that are closely application related. So you'll have things like messaging and state management. Now, cross-cutting concerns and application-related concerns are, again, not natively supported by Kubernetes. This is the focus of Dapr. So let's start with looking at one such concern, which is messaging or asynchronous communication. So in a non-Dapr case, you will have a service that wishes to publish some sort of message onto a event broker. And in typical fashion, you will have some type of client library that you initialize. And this is baked directly into application code. You'll have a dependency in your code base on, in this case, AWS and the SNS service. And you'll use whatever API that the SDK offers to publish this message. Again, every service that wishes to publish a message and also subscribe to a message will have to bake this dependency into their project. There are a number of issues related to this mode of implementing messaging support. Of course, we already saw one, which is managing a dependency. So you'll have to make sure that whatever client library driver you're using to interface with, in this case, the Amazon SNS service, actually matches the capabilities and version of SNS. Therefore, you're also, quote-unquote, tied to this infrastructure. You're using a vendor-specific SDK, which means you're relying on any type of configuration, resiliency, policies, observability features that SDK offers. And there are, of course, security aspects. You have to acquire credentials somewhere, somehow. to connect to SNS. And you might also have to establish access control policies. Only the proper publishers can perform their publishing of messages. So let's step back and see if we actually want to continue this mode of operation, or if there is a better way to solve this. So what is the actual abstraction we're looking for? This is basically it, as far as I'm concerned. I want to be able to publish a message to a topic. And all those issues we just saw, hopefully, will be shielded from me or configured transparently. So in my application code, this is what I'm mostly concerned with. Of course, I want to be assured that some of the guaranteed semantics of publishing a message through only this abstraction will be well-defined and present, like at least once delivery, that the message format is something I can rely on, etc. But more or less, this is the abstraction I'm looking for. And as they always say, nothing has ever been not solved by introducing another layer of abstractions. So here we go. Where can we find this abstraction? In Dapr. So this runtime will enable us to level up, if you so will, and take advantage of this simple way of publishing, in this case, a message to a particular topic. You can think of this as one building block among many. So if you look at the Dapper architecture, you'll see that it enables us to interface with a number of useful building blocks through any type of language or platform, basically via HTTP and or gRPC. So the runtime itself supports, as you can see, everything from basic service invocation to pub/sub messaging to working with configuration and secrets in a standardized way. We have some esoteric blocks like distributed locks, actors. Something that I'm very fond of is workflows. But again, all of these application-related concerns served via these building blocks, we can interface with in our code, again, any language, any platform, quite easily with an HTTP API. And then underneath, you have your cross-cutting concerns, your resiliency policies, your security policies, and basically automatic observability instrumented and provided for you. And then the actual resources you are implicitly interacting with, like databases, with actual pub/sub infrastructure on Amazon or Google, all that is, again, shielded from you. The way you connect with them implicitly or indirectly is through these building blocks. Again, since these are sort of features that span across many building blocks, you will, for example, see distributed tracing supported not only between one service and another in a direct call, but you can carry that on if you do a pub/sub, for example. So the trace will sort of continue on from the synchronous call over to the asynchronous communication flow as well. So let's look at the building block that we are currently looking for, which is pub/sub. So again, this is a standardized API that the Dapper community has settled on and formally supporting in the runtime. And each building block, if you think of it as an API/interface, it will have a number of implementations. We call them components. One such component, in our case, since we are relying previously on AWS and the resources therein, is a component supporting this type of messaging. So one component you will find, an implementation for this building block of pub/sub, is AWS SNS coupled with queues through SQS. This is sort of the fan-out pattern that it supports. So again, the building block gives me the API and semantics across all supporting components. For example, again, at least once delivery, cloud events as the format, etc. And I will choose the type of component, the backing implementation that is relevant for me, again, based on maybe existing usage of AWS infrastructure. So how does this get wired up exactly with my application? So first of all, we need to install Dapr in the Kubernetes cluster. So we'll have a control plane for Dapr. And Dapr uses the sidecar model. So in my pod, next to my application container, I'll have a Dapr sidecar that gets injected, given that I've annotated my deployment with it. And this sidecar, again, will accept incoming calls from my application and then interact with the component, in this case, again, SNS, that is being provided by the components. Now, be aware, though, that this is for one cluster or intra-cluster only. Dapr doesn't support multi-cluster setups, so to speak. If you want to enable Dapr and communication across clusters, you have a certain option for it, but Dapr itself is something you install in a single cluster and then operate. There are tools out there, especially from Diagrid, the company that formerly backs Dapr, that provides tools to orchestrate and manage multiple Dapr clusters. So given that this is how my application will be instrumented with Dapr, let's see what the previous example, where I had the actual dependency in my code base, now gets decoupled from AWS using Dapr. So on the left, you'll see the component that we want to create. And this gets applied to the cluster. And this is a component, again, supporting the pub/sub building block. You can see then that the type of component is pub/sub.SNS SQS. So that's the proper one in our case. We can then provide configurations, such as the region. And that, again, gets instantiated in the cluster. Now, our code, the payment processor service in this case, utilizes a Dapr client, an SDK that is available for many types of languages. You can also do a regular HTTP call if that's what you want to do. But in this case, we're using the JavaScript Dapr SDK to publish our message to a certain topic that this component allows us to do. So the abstraction that we saw earlier is more or less what we see here in our code sample. Now, another important point is that our service gets an ID that is stable, the payment processor, and we can use this app ID to, for example, scope access to the component. Who gets to publish something to SQS, or SNS SQS in this case? So we can, for example, say that, yes, this application, or rather this service with the ID of payment processor, is allowed to publish something to, or via this component. We can then restrict other services from doing the same thing. We can also target specific services with resiliency policies, circuit breakers, and specific configurations if we so choose. And of course, credentials can be also transparently acquired and used. That's not something our application, our call to pub/sub will have to deal with. Just one note here is that in this case, actually, our topic and queues in AWS will get automatically provisioned. That's usually not the case, not something you should rely on. Actually instantiating the resources in a cloud provider that you want to interact with is something you'll have to do yourself. We'll return to that later when we talk about platform engineering with Dapr. But the component is what glues our code together with the resources in our cloud provider. So this was pub/sub. Another very useful and common building block is service invocation. So here you see one application service directly calling another one, but it does so through the sidecar. So you'll see that the invocation, the URL is slightly different from what you typically would use in your calls with straight-up Kubernetes. And here you see some of the extra tag-ons, you might say, that go along with service invocation. So you have pluggable service discovery. Again, in Kubernetes, you will use Kubernetes DNS for this purpose. You can configure the resiliency policies, what will happen if checkout doesn't respond, what are the timeouts, the retries, etc. You have encryption and MTLS authentication on the network layer. You have instrumentation, so you can get your distributed traces more or less directly without a lot of setup to whatever backend you desire, like Zipkin, for example. So a request goes from the application service called customers via its sidecar, routed to the sidecar that intercepts it on the checkout side, and then the Dapr sidecar there will post to an endpoint that I establish within my checkout process. What do we achieve with this type of architecture? You might call it application portability. So we already have that to some degree, to some extent with Kubernetes. You have your compute being portable from one vendor to another if you're using a container-based approach. Now we get the same for integration with various services, irrespective of what cloud provider you're using, or even your own deployments if you're on-prem. So if your organization has a policy of becoming or being cloud agnostic, you now have both the compute and the integration layers taken care of. Which also means that if you want to now do some switches, for example, you want to phase out an existing database for another, you want to upgrade versions, you need to re-architect your solution, you have to instill policies of various kinds for resiliency and access control. All of these are portable, and it makes it easy to switch a provider, say, if that's what you need to do, or deploy among many different providers. Especially the skill set is something that is particularly critical. Once you become onboarded as a developer with the Dapr, it's transferable, of course, to a new re-architected application, or if you're in a greenfield situation, straight up using those building blocks that you need in that case. Again, if you're talking about compliance, you maybe need to implement auditability. If you use Dapr to do that, again, that whole architectural characteristic becomes portable as well. So we're not just porting applications, we're talking about porting what people know about developing applications, experiences, and so forth. So Dapr brings a lot of this into it when it comes to, again, becoming portable in various ways. Maybe most critically is that you don't have to embrace all of Dapr at the same time. These building blocks are independent. So you're just happy with service invocation, go with that. If you need to add pub/sub in a standardized way, employ that building block. So if you're migrating from monolith to a more service-based solution, that's a prime opportunity to get those building blocks into your development. So how do we know what type of building blocks that are of interest when we design our applications? How do we make those choices? So one thing I'm fond of is always to model the business domain we're in and try to derive a system architecture from that. So I like to use event modeling to understand the business flows in a certain business domain. And I'm not going to spend too much time on what event modeling is or how it works, but more or less you can see a business flow as a series of vertical slices from left to right over time. And what we're modeling is a system and how its state changes over time. So this is a simple event model of a bike rental service, a scenario in this case that relates to basically going to a bike station, requesting a bike, and then picking it up. So if we start with the first vertical slice, it's just a matter of my requesting a bike. So you might see a panel at the station where I'm entering my information. A request, an HTTP request, reaches a backend that processes request, and then it persists the event, the state transition that happens, that a bike is now being requested. This state transition, this event, will then update a view of, or you can say a to-do list of bike requests to process, because the station now has to select one for me. If we start with these two slices, the vertical one and sort of the diagonal one, we can see that the first slice, we're going to require service invocation, because there will be a bike management context / you can think of it as a service that the API backend will invoke. And the bike management service is the one that actually understands that part of the domain. So we'll need to employ a building block for service invocation for the first slice. And we'll also have to use a state management building block. We need to persist this change of state. And this building block for state management has a number of back implementations going from Redis to SQL-based DBs, etc. If we go to the next slice, you'll see that we have a list of available bikes. Again, the domain service that will select a bike for me needs to be able to read that information, so we'll use a state management building block as well. And when we update the state for requesting a bike, there will be a number of requests piling up. Again, using the state management building block, but in this case, we'll add pub sub and get a transactional outbox. That pattern is something that Dapper adds on top of this. So when I update the bike request's state, there will be an event sent out immediately to the selector to start selecting a bike for me. I don't have to configure much to make this happen. I'll simply have to employ both building blocks to make sure that they act as an outbox. And on we go with each slice. When we get to the part where the station unlocks a bike for me, there is actually a lot of things happening there, which you can think of as a workflow. So the slice that begins with the unlocking of a bike means that I now have 60 seconds to pick up my bike. If I don't, the bike will be locked anew. So in Dapper, we have this building block, which is quite sophisticated to orchestrate workflows. So we can start a workflow to manage that whole sequence, those other slices that follow. Now, when we unlock a bike, we'll also have to notify myself, maybe in a mobile app or a lamp on the station that signals that this slot is now the one that I should approach. We can use another building block called bindings to interface with an external system. So using an output binding, as it's called, we can connect with the internals of the station to make sure that it starts blinking at the correct slot. And we'll end the workflow once I've picked up the bike, because then there will be a sensor that recognizes the bike has now been picked up from the slot. And there will be an input binding instead that tells the workflow that, okay, you can finish off the workflow because the bike has now successfully been picked up within the allotted time frame. So what I like to do is first model the business flows, and then for each slice, try to identify what Dapper building blocks my system architecture will most likely have use for. And this gives both the domain experts and the technical experts one nice flow to look at. I can then go further, so I can take these slices and these building blocks and construct, say, a C4 diagram. So here I've tried to arrange the dependencies, or rather relationships between various parts of my system. And for example, I will have a workflow service that encapsulates the unlocking of the bike, etc. And I'll also make sure to note what type of building blocks it uses in terms of interfacing, say, with the bike management service invocation. The workflow service needs to contact station internals, an external system. It will use so through an output binding. It's very nice to have a compact way of illustrating all my building blocks and what terms of how they actually relate between various parts of my system. So let's just take a bit more look on the workflow part, because that is quite interesting. So we get through this building block a general workflow engine that you can write directly in various types of languages, the types of activities and patterns that are meaningful for example, a bike rental flow. And it's durable, so should, again, something crash and you need to resume, the workflow will be able to start off where it left off. And again, the nice part here is that directly interfaces with other building blocks, like service invocation, pub sub, so we'll have use for those when we design our workflow. So if we take that unlocking of the bike, what will it look like? Well, here we'll use the wait for external events pattern. And it will become something like this. I, as a bike renter, I will see that this bike is now available to be picked up. The first activity is called notify renter, and it will, through an output binding, that building block, signal it through a blinking light at the station. When I pick up the bike and the sensor is triggered, it will use an input binding to talk back to me, back to this workflow, and tell me that the bike is now being released from the slot. It's been picked up. So that happens within 60 seconds. I simply update the state of my system about the available bikes. But if I don't do it within 60 seconds, they will time out and the bike will be locked. And that's when the workflow ends. So I think this is maybe going to call it a game changer, but it's one of the very appealing parts of Dapr. This workflow engine that is, again, portable across various environments. Sometimes Dapr doesn't provide everything for you. So remember those events that you saw in the event model? There are cases where those events can become the single source of truth for your application. So you might be aware of something called event sourcing. If that's the data access pattern that we want to utilize, well, we would like to have an event store to actually store these events long term. Now, how do we get that type of capability through Dapr? Well, we can't. Had there been a building block in existence that had those semantics built in, we could just maybe build our own component or use the ones that are available. But no such building block exists for an event store where we append and read events. So what do? Maybe you can create your own building block, but you need to go through a community process. This needs to be formalized. It needs to be included in the Dapper runtime. And that, if it's accepted and liked as a building block, it will take some time. So you're left with input and output bindings. Again, a building block for interfacing with external systems. And that you can do. You can have your event store and use these bindings to interact with it. And you can register your component as something that is pluggable, because normally components will be known to the runtime statically, but you can add these dynamically. So If I want to use an event store, and my only option is input and output bindings, what's a possible setup in that case? Well, I'll have my application or service, and these commands and queries that we saw in the event model, they actually become messages that I can send and receive. So we're doing away with service invocation. Bike management is no longer a service you can synchronously call, but instead you construct a command, an actual message. And you have a component that knows how to take care of it once it's sent through the sidecar. Because that component, the event store component, will then utilize, in this case, what's called Exonic. It's a commercial offering for performing event sourcing. They have an event store, but they also have this notion of messaging. What is a command? What is a query? So I construct a component for Dapper. I can then route these commands through that via the Exonic tech stack to the event store where it's processed and where event sourcing is actually performed. So that's where I will generate and store my events. I can then also query, so I want to know how many bike requests are there. I can send a query through my component and then get a result back. And again, I have an input binding as well, so if I perform a query and I want to get results over time, it's possible for me to get them over time via sort of a push mechanism. So in this case, we simply relocate everything related to bike management as part of implementing that slice, but with an event store. But the way for me to interface with it will be through a custom component utilizing the building block input and output bindings. This is one way to do it. Now, what we just saw was a way to extend Dapr, where a building block wasn't available for what I had to accomplish. So you will end up with circumstances where you can't avoid dependencies directly. Again, Dapr covers a lot of use cases, but by necessity it can't cover everything. There is a compromise here that we make. Standard building blocks that cover maybe 85, 90, 95% or whatever you want to build. But there will be cases where you will either, as we saw on the last slide, build your own components or interface directly with a resource that you don't have support in Dapr for. So in this case, we have an application service using the state management building block that supports state storage in Postgres on AWS. But we also suddenly get the requirement that we need to perform some specific SQL queries. There is no SQL building block, so we need to interface directly with the database. What do we do then? We encapsulate whatever that entails in a separate service, and that will have direct access to the database. Again, we're back to having a dependency on a library in that service, but we can sort of isolate that dependency to only service B. And between service A and B, we regularly use service invocation. That's fine. But this is one way of sort of minimizing the, what do you call it, blast radius or impact of having to directly interface with the database. This is quite common, and it's hard to avoid in a reasonably sophisticated system. Why is a SQL building block maybe not that interesting in the future, maybe? Well, SQL is a standard, is a way to interface with a database. It's not exactly something that has multiple different types of backing implementations. So every SQL supporting database follows more or less the same semantics, table-based. State management is a pattern. You can do that with Redis, a key value store. You can do it with a document database. You can do it with a SQL database. So there's a qualitative difference between that type of building block and what a SQL building block would mean. Doesn't mean that there won't be in the future, but there is a distinction there that is important to observe, I think. Now, we come to the last part of this exploration, which is how Dapr ties into platform engineering. I mentioned previously that Dapr is only the glue that connects you to certain cloud resources. It doesn't provision them. It's something you still have to take care of yourself, and you should. But Dapr, combined with necessary tooling for this purpose, becomes quite powerful. So what is platform engineering in a nutshell? Very briefly. As an application developer or as part of an application team, I would like to have some sort of abstraction I can use to instantiate resources on my platform. So if I need a database, a platform team can create an abstraction called a database that I can apply to my cluster directly in a local environment or through GitHubs. But I can use a YAML file like this to specify that I need a database. In this case, I actually wanted provision on AWS. And there are custom parameters that can be specified. Whatever small means is what I will get when this gets applied. The platform team will make sure that the underlying so-called composition, all that makes this happen on AWS, gets instantiated and provisioned. And there is a specific tool for this called Crossplane, which the platform team uses to build these compositions. I, as an application developer, will use this YAML file to say, give me a database on AWS, and I want a small one. Inside of the cluster, Crossplane will do whatever it needs to do to reach out to AWS and create a database. You can think of Crossplane as a general control plane to control any type of resource, and I do mean any type of resource, on any cloud provider. So if you have Crossplane for actually creating the resources we need in a cloud provider, and I use this type of interface to the platform, this is my API as an application developer, I still need my Dapr component to somehow connect to all of this. So here we see sort of the flow, very simplified, to wire up Dapr and Crossplane. Again, I apply a YAML file to the cluster. Crossplane will notice this and start to provision the so-called composition, all the details related to the database. So it will make sure that it contacts AWS and start that process. At the same time, it will also create the Dapr component for me. So the state management component will be included in this process. And once the database has been created and I need some credentials, that component will be loaded with it. And then I have my application, and I want to connect to AWS, albeit implicitly, through my component. Everything will be wired up correctly for me to do so. So if you use Dapr and Crossplane together, you now have more or less complete decoupling in terms of my application code and the resources it depends on. But we have a unified way of connecting ultimately my application with the resource in question, which is AWS database in this case. So, what's the takeaway or takeaways from this? Again, what does Dapr give you? Well, we have a set of APIs. We call them building blocks that you can utilize from any language or platform to access cloud-native capabilities. They also give us specific patterns, so things that are common to use in a cloud-native environment is something that Dapr layers on top of some very basic primitives, if you so will, like the transactional outbox. Dapr also gives us, thereby, a sense of portability. So we can become cloud agnostic. We can re-architect our application. We can build upon previous knowledge in how we build our application using these unified APIs for communication, state, workflow. Furthermore, as we just saw, we have a separation between application and platform concerns. So we can provision the resources we need. We can instantiate the Dapper components that we need as a glue between our application and those resources. But the way I, as a developer, interface with those resources are cleanly delineated for me through these cross-plane abstractions. And again, most important, do not see Dapper as an all or nothing proposition. We can choose the building blocks we need to start our adoption of Dapper in the ways that we see fit or that are required of us when we start out a greenfield application or something they need to migrate. So if this has piqued your interest, check out dapr.io. You'll find much more information about each building block there. What I wanted to highlight here is the way Dapper actually, again, works in practice, and some of the considerations you have to keep in mind as you hopefully start exploring Dapper more on your own. So, do reach out if you have any questions. I'll be around for a little while before heading home, so hopefully see you out there. Thank you. Maybe you have some questions.
Yeah, maybe a question, Mark.
Yeah.
You said that so Dapper really delivers a nice layer of abstraction, but you also need, or that's something you highlight, kind of the platform engineering approach to also provision things. That's where cross-plane comes in. How much effort is it to actually get started with all that? What's your experience in that? Is that something easy, or is that quite still lots of work to do to get that platform bootstrapped, actually?
It's not an easy undertaking. It isn't. Because, again, this crossplane, if you choose that option, you need to be able to understand how it fits into the control plane scheme of things. So, and it has a bit of a learning curve. There are other options out there. I found just crossplane to be a good match with Dapper. But either you have those resources, personnel resources in your organization that already know these facets of platform engineering, maybe have a slightly easier time to adopt crossplane or similar tools for provisioning resources. It's sort of the point that you, as an application developer, should offload this concern to someone else, if possible. But if you can't, you at least have, I would say, some standardized, quote-unquote, path to do it, and some very good tooling for it. But getting started on just with the Dapper side, hopefully you can see it's quite easy. It's not too difficult. The other part, when it comes to actually connecting it to resources live in a cloud provider, yeah, that's a bit more of a involved process. But they are complementary. So hopefully you have this divisions of app and platform teams working together to accomplish it in maybe the manner that I displayed. Yeah. But yeah, definitely do not mistake the provisioning part as something we'll do at the very end. No, it has to be part of the grand scheme of things.
And is there any effort in the Dapper community to kind of also support an easier way in then? I mean, it is all possible, but the step up is still something to do. I would assume that everybody is kind of facing more or less the same problem there.
Yeah.
You know of any kind of, projects or maybe part of a roadmap on Dapper to actually also support that on a more higher abstraction level?
So sometimes you have this, and I shouldn't speak too much about it because I haven't used it myself, but if you're, for example, using Azure Container Apps, and since Dapper is a Microsoft project from the start, you have this, I think, much more deeply supported in Azure using Container Apps than the sort of bare bones scenario I had in the presentation. I know that Dapper is very helpful in the community, is very helpful in making this happen and providing tips. There are articles how Dapr fits into Crossplane and other tools like Cratix. So you have some guidance available, but since platform engineering and resource provisioning is a giant beast in itself, there's only so much I think they have the bandwidth for. So that's sort of where I found a sweet spot, because I'm interested in both parts of or both sides of the coin. So yeah, there are resources out there for sure that will help you get you towards a good path forward.
Thanks a lot.
Thank you. All right. Thank you very much.